Good day. Dear colleague, we would like to present you our work, evaluation of loss probability and average storage time for limited processor charging system with FCFD protocol. Processor charging disciplines are widespread in communication system and computer networks. The basic principle to organize the request for the processor time is a job alternately served during small intervals of time. The implementation of this principle to organize the computing process is carried out using a scheduling algorithm. The principle of service quantization is a way to reduce the response time of the system to short jobs due to the delay in processing long job in the absence of information about the retaining time of job. Processor charging is efficient in the sense of delay minimization is a service time variation of higher than the variation of the exponential service time distribution. Leonard Klimrock was the first who considered this approach. In the case of egalitarian processor charging, all jobs contained in the system at present time are served with the same rate. The system with unlimited egalitarian processor charges, the stationary state distribution is the same as the MM1 quorum system with the first input, first output discipline. In a particular case, since that the total service rate is constant, one may suppose that each job is served with rate 1 by I, if I jobs are in the system. The version of the discipline, a certain minimum charge in the bandwidth of the computer or channel, has to be guaranteed to provide acceptable quality of service to a customer. Therefore, the processor charging with a finite capacity or limit processor charging is often used. In this paper, the quorum system with the limited processor charging was studied. You can see the scheme of model of egalitarian processor charging. In accordance with first come first displaced protocol, the job right first is interrupted. In the mention of the paper 5, that the FCFD discipline is useful when the importance of call decreased with the lapsing time. A loss system was considered in which jobs of higher priority preps the service of lower priorities. In 6, an approximate approach was developed to compute the average Sojourn time for the limit processor charging system with FO choosing job from the buffer. This current system was interrupted in a mathematical model using to evaluate characteristics of the mobile connected between drivers moving on a highway or between driver and the faculty located on the same highway. You can see this picture that shows a concept of a vehicle communication system. The paper considers a quorum system with limit processor churn in the maximum and viable number of jobs is in the system and the new jobs arrives, then the job that arrives first is lost. This rule is useful in communication networks such that the importance of information decrease in time. Formulas are obtained for the loss probability and the average sojourn time. The formula for the loss probability with limited processor churn with the shortest remaining length job loss rule has been also obtained. In the case of constant length of job, the loss probability is the same as in the system with FCFD protocol. We consider a limit processor sharing system with arbitrary arrive process and arbitrary job length distribution. There are no more than n jobs in the system. If n jobs are served, a job arrives and the length of this job is less than the minimum remaining length of any source jobs, then the arrival job is lost. Let C of t be the service rate at time t. We assume that the job is not served at time t. Then C of t is equal to 0. Let the job arrive at time t1. Then the service job ends and this integral is equal to L, where L is the job length. We consider two processes, x of t and x hat of t. Denote by p of I of t the probability, this probability, and p hat of t this probability. Then we have proved this theorem about velocity probability of that process x of t is equal to I. Then, if input of the system S1 is a person, we have this formula. And this is the value you can see in this frame. The loss probability for a loss quorum system with a pause and arrive process equals the probability that all servers are busy. Therefore, the stationary loss probability equals Pn. The follow theorem. We have to evaluate stationary loss probability by this formula. We consider quorum system that differ from the system considered above. If there are n jobs in the system and a new jobs arise, then the arriving job interrupts the service of the job that arrived first. Assume that job length has the following distribution. Then the follow theorem is right. If relation 1 holds for the job length distribution, Then the system S1, the stationary state probability, may the computer as follow formulas. And continue this one. And the stationary loss probability is equal to Pn. Then we, in the proof of this theorem, we use the Laplace TDS mapping. And we have find the stationary probabilities. Suppose n is equal to 1. Then this relation holds for any distribution of drop lengths. Using the computing stationary probability in the possible to compute the loss probability D and average number of drop L in the system, D is equal to this ratio. L is equal to this one. Using formula of little, we obtain this velocity evaluation. This velocity is a sojourn time. If lambda 1 is equal lambda 0 is equal lambda n is equal lambda, that the little formula is this one. This one. One uses this formula, the relation alpha by mu with the average length value b. So we exact formulas obtained and approximate approach is proposed to compute the loss probability and the salvage time for a loss scoring system with limited processor sharing and the FCFD rule for choosing the job such that this job is lost if all servers are busy and the new jobs arrives. The system may be applicable to model communication system in which the importance of information decreases with the elapsing time. The formula for the loss probability with limited processor sharing with the shortest remaining length job loss rule has been also obtained. In the case of constant length of job, the loss probability is the same as the system with FCFD protocol, and this value of this probability is the upper boundary for the loss probability in the system with FCFD protocol for any distribution of job lengths. Thank you very much for your attention, and we wish you all the best.